EIGRP offset list. In this video, I'm going to talk about the feature of the EIGRP. We call it the offset list. Okay. First, we should understand what is the offset list and also how the offset list is working. After that, we can talk about the usage of the offset list. Here, we have a simple scenario, R1 connected to the router 2 with one serial link, and also we have two loopback interface with these two IP address. Okay, I'm going to show you only the EIGRP offset list feature, okay, not the usage of the offset list, okay, here. After understanding the offset list, I will talk about the EIGRP offset list functionality. Look at here, you know that R1 connected to the router 2, and here we have EIGRP as the routing protocol between these two routers. Okay, this is the EIGRP. You know that because here we have neighborship between the router 1 and router 2, the R1 should send two updates to the router 2. The first update is quad 1 slash 32, okay, and the second update is quad 2 slash 32, okay. This is the normal behavior of the EIGRP, and you know that the R2 is receiving these two updates. Let me to show you. I have configured this scenario before. As you can see, show IP EIGRP neighbors. We have neighborship between the router 1 and router 2, and this is the routing table of the router 2. Show IP route EIGRP. Look at here, we have received these two routes, the quad 1 slash 32 and quad 2 slash 32 from the router 1, and we have connectivity to these two networks from the router 2, ping quad 1 and ping quad 2. Okay, this is a normal behavior without any for example new configuration. Let me to show you the configuration also. In router 1, show run section router EIGRP. Okay, show run section router EIGRP. As you can see here, we have router EIGRP 1, network quad 1 quad 0, network quad 2 quad 0, network 10121 quad 0. The 10121 is the IP address of the serial 10 interface. And here, show run, for example, section router EIGRP. As you can see here, we have router EIGRP 1, network 10122 quad 0 command, and you know that this is the IP address of the serial 10 of the router 2. Okay, now what is the functionality of the offset list? Don't forget, now I'm not going to talk about the usage of the EIGRP offset list. I'm going to talk about the functionality of the offset list. Okay, with the offset list, you can tune, okay, the metric of one route. For example, assume that in the routing table of router 2, this is the routing table of router 2, show IP route EIGRP, we have this metric, okay, for the quad 1 slash 32 and also quad 2 slash 32. This is the routing table of the router 2. Let me to show you. In this routing table, we have two routes. For the quad 1 slash 32 and quad 2 slash 32, the metric of each route is, for example, this value. This is the metric of the first route, and this is the metric of the second route, same metric. In some cases, maybe you want to increase the metric of one route. For example, you want to increase the metric of the quad 1 slash 32, for example, with 1000 value. You want to increase this value with 1000 value. So easy. Okay, maybe you ask me why I should increase the for example, metric of one network. I will talk about the usage of this, but here let me to show you. Assume that this is the default metric, okay, and now we are increasing the metric with 1000 value. This is the offset, okay, this is the offset that we are giving to the metric, and finally you will have this metric. Okay, so easy. I will talk about the reason of increasing the metric and the usage of the increasing of the metric, okay? Or you know that this is the feasible distance. Actually, we are increasing the feasible distance of the quad 1 slash 32. First, let me to talk about the method of configuration. After learning about the offset list, okay, we will talk about the usage of this. But until now, we have learned that we can increase the metric. Maybe you say me that we can increase the delay of one interface. Yes, if you increase the delay, or for example decrease the bandwidth, this change affect on all links, on all routes, okay, in some cases we don't want to affect or change other routes attributes, okay? Only we want to change the metric for one route, for example for the quad 1/32. Because of that we should use this feature. This is the offset, okay? Look at here, 1000 is the value of the offset. Now how we can configure it? It is so easy. In the router 1, okay, you can give offset in two places. The first place in the router 1, you can send quad 1/32 with one offset value. I will talk about the detail of this, but for example you can say when R1 is sending quad 1/32 to the router 2, it should add, okay, this offset value at offset, for example 1000. This is the offset in outbound direction, means when the R1 sending the update over the, for example, serial 10, it should add up the offset to one update, for example, or maybe more than one update. This is the outgoing offset. In some cases you can configure in the R2, when R2 receiving the update from the router 1, okay, it should add, or from this interface, for example on the serial 10, it should add this amount of offset to the for example one route. This is the inbound offset. I will show you both of them. First, how we can configure outbound offset, means router 1 should send the offset for one route. It is so easy. Look at here. Here we have the command of offset list in the traditional EIGRP, router EIGRP AS number, offset list. Okay, first you should configure the one ACL. This ACL is using for the, for example, identifying the routes that we want. After that, we should identify the direction of the, for example, offset list, and then the offset value. Let me to show you here in the router 1. It is so easy. The configuration of offset list is so easy. Look at here. In the router 1, we are configuring one ACL access list, one permit, a quad 1, then a router EIGRP 1. Here you can configure offset list. What is the list? List means ACL number or ACL, for example, name. Here the ACL number is 1. Let me to use the offset list 1, okay? And after that, outbound direction, the value of offset is 1000. And if you want, you can identify the outgoing interface. You know that if you don't identify the interface, this offset is applying to all interfaces, but here we are limiting the scope of offset over the serial 10 advertisement. That's it. This is the configuration of the outbound offset list. Okay, also if you want, you can configure the offset in the inbound direction. Let me to show you again. Access list 1 permit quad 1 router EIGRP 1 offset list 1 inbound, okay, or IN, and then this is the offset value, and then over the interface serial 10. Okay, and also if you want, you can exactly do the same function in the named configuration of the EIGRP. Let me to show you here. In the name configuration, we are using router EIGRP name, and then router config router, okay, address family, again address family, IPv4 unicast autonomous system,